We are now going to continue our study of significant figures and apply it to calculations. There are different rules depending upon the type of calculation you're going to do. Adding and subtracting, we're going to round our answers to the least number of decimal places. Let me run through this example to make this make sense. So here in the number 3.4, we have one number after our decimal. The second number, 4.56, there are two numbers after the decimal. And the third number, there are three. We want to go to the least amount of decimal places for our answer. So our answer should only be to 1. So you go ahead and you do the math in your calculator. You should get something like this, 16.07. You only want one decimal place. So I'm a visual person. I like to put a little marker right there, and then you look at the number right after that marker. Because it's a 7, it's going to round that 0 to a 1. So the correct answer to this problem would be 16.1. When we're multiplying and dividing, instead, we go back to our normal rules. We're going to round our answer to the least number of significant figures, what we just discussed on the previous slide. So here, this number is 2 significant figures. Remember, zeros at the end don't count if the decimal is not shown. And here, this is 4. So your answer should be to 2. Go ahead and do the math in the calculator. You should get something like 356.86, and then the number continues. We only want 2 significant figures, so I count 1, 2. I'm going to put my little marker. That 6 is going to round this 5 up. So I get 36. This is incorrect. I cannot round 356 down to 36. So what I have to do is use a 0 as a placeholder. So the correct answer to this one would be 360. Now it's your turn. What I would like you to do is I would like you to solve all of these problems. Okay? Either looking at numbers of decimal places or actual sig figs. At this time, please pause the video so you have a chance to complete them. Please check your answers to the problems. If necessary, pause the video to be able to do so. The last 2 questions under each column I would like to discuss. Let's do the addition and subtraction first. So there's 2 decimal places here. There's 4 here. When you actually do the calculation, you get a different number. But then when you do your rounding for the correct number of decimal places, it rounds back to the original number. That is totally okay. For the very last one on the multiplying and dividing side, this here is 4 sig figs. This one is 2. What ends up happening, unfortunately, when you plug this into your calculator and you round, the answer you get is 300. Well, 300 by itself is only 1 sig fig. Sometimes we can remedy the problems by just putting 300 and adding a decimal. Unfortunately for this one, when we do that, this now becomes 3 sig figs. I only need and can only have 2. So this is an example where I needed to put my number into scientific notation. We're going to do a quick review of that on the next slide. Scientific notation is defined as a given value expressed as a number written using exponents and powers of 10. And like you saw on the previous slide, sometimes it's necessary to get the correct number of significant figures. This should not be a new concept for you, but we are going to review it. To convert in and out of scientific notation, if we're moving our decimal to the right, because the number is small to begin with, we're going to end up with a negative exponent. If we're moving our decimal to the left because the number is large to begin with, we're going to end up with a positive exponent. You always want to make sure that you put the decimal after the first non-zero digit. So let's do an example of each, and then you'll have some time to practice. That first number there I want to put into scientific notation. The decimal is not shown, but it's present right there, and you're going to move 1, 2, 3, 4 spaces to the left. So we're making a large number smaller. So this is 3.1, and it's going to be times 10 to the positive fourth, because I moved the decimal left. If I jump down here for a moment and I take it out of scientific notation, a positive exponent means a large number, or a larger number. So 5.4 to the second, now I'm going to go the other way, so I'm moving my decimal 2 spaces to the right to get 540. Please pause the video and try the remaining practice problems. Please check your answers. For the smaller numbers, they have a negative exponent, and for the larger numbers, they are positive. When you have a negative exponent provided, you make the number smaller, and when you have a positive exponent, you make the number larger. You always start exactly where the decimal is, so I want to move it 5 spaces to the right. 1, 2, 3, 4, 5. And of course I fill in with zeros. The next part of the chapter is most likely a review for you of the metric system. The metric system is the universal language of scientists. Some of the base units that are very common are grams for mass, liters for volume, meters for length, and so on. When we convert, there are multiple ways to do this. I like to just use this. Okay. The placeholders are there because you need to take them into account as you're moving your decimal. The B stands for the base, and this will be if it is a single letter. So just grams, or just liters, or just meters, or just seconds. The capital M is mega, the K is kilo, H is hecto, the capital D is deca, the lowercase d is deci, the C is centi, the M, if it's the first letter of 2, is milli, the U is kind of funny looking, it stands for micro, and the N is nano. So if we're going to use this, you're going to identify where to start, identify where to go, and then move your decimal accordingly. So let's do this first practice problem together. An M by itself is a single letter, so we're going to start at the base, and then the MM means we're going to go to the M. So I'm going to go 1, 2, 3. So I'm moving my decimal 3 spaces to the right. 1, 2, 3, and I'm going to fill in with my zeros. So I get 5,600. Please pause the video and try the additional 3 problems. And here are your answers. It is really important that you remember when the decimal is not shown that it's at the end of the number. So here we're going from this D to M. So you would count 1, 2, 3, 4, 5. Yes, those placeholders count. So you move your decimal 1, 2, 3, 4, 5, and you of course fill in with your 0. There's additional practice on many of these concepts available on the course website. Now let's talk about another really important concept in chemistry, dimensional analysis. It's a technique or process used to convert from one unit to another using something called a conversion factor. A conversion factor is a special one, a numerical factor that is used to change one unit to another. It's really like an equality turned into a fraction. For example, we all know that 1 foot equals 12 inches. If I want this to be a conversion factor, I can write it like this: 1 foot over 12 inches, or I can write it like this: 12 inches over 1 foot. It really depends on what the question is asking. Let's discuss dimensional analysis in a little more detail and try a practice problem. I like to give out general equations for things, and I will throughout the semester. Some people like them, some people don't. You'll kind of see after we do the example what it means. So it's going to be question mark what you want or what you're looking for equals your given value in the problem over 1. The 1 is just a placeholder, and I like parentheses, times my conversion factor. Sometimes there's more than one conversion factor to get to where we need to. These conversion factors will be provided to you. You are expected to know things like there are 12 inches in a foot, there are 60 seconds in a minute, there are 24 hours in a day. But other than that, they will be provided. So let's do this example and apply the general equation. It says a student has entered a 10-kilometer run. How long is this run in miles? So we're looking for miles. Please use MI for miles because M is meters. Then in the problem, the only number provided is the 10 kilometers. So that's my given. So it's 10.0 km over 1. And then here's your conversion factor. You're going to have to turn it into an actual conversion factor from the equality. So we need to get rid of things. If I take 100 divided by 100, I get 1. 50 divided by 50 is 50. So km divided by km is a 1. So we need the km to disappear. So it's a diagonal drop. So since km is on top here, km is going to go on the bottom here. And since I'm looking for miles, it's going to go on top. And then I keep the number with its unit. So 1 mile is 1.609 kilometers. If you find it helpful, you can cross out the units, so the km's go away, and then you solve the problem. Mathematically, however, is easiest for you. For me, since there's a number on top and there's a number on the bottom, I just divide, because I know that that's division. So I go through and I solve the problem. You're going to get something like this. But you have to record the proper number of sig figs. So we go back to our given. Our given is 3 sig figs, so we need our answer to also be 3 sig figs. So that 5 rounds that 1 to a 2. So the answer will be 6.22 miles. And I know what you're thinking. Yes, there is an easier way to do this, right? You could just divide it in your calculator. However, these problems are going to become more and more complicated throughout the semester, and therefore it is really important that you learn this process, because this process is what is being tested. In our next video, we will continue our study of dA and the remainder of Chapter 1.